Hello and welcome to Maths on the Move, the podcast from plus.maths.org. I'm Rachel Thomas. Now, there are some people you never ever tire of listening to, whether they're telling you good news or a funny story, or whether they're telling you something really worrying, like statistics regarding COVID-19 when you're in the middle of a pandemic lockdown. For us here at plus.maths.org, one of these people also happens to be probably our favourite statistician in the whole world, Professor Sir David Spiegelhalter. We've been lucky enough to work with David for many years, and he is often known by many people as Professor Risk. He's also currently the Emeritus Professor of Statistics at the University of Cambridge, and he's just written a new book called The Art of Uncertainty: How to Navigate Chance, Ignorance, Risk and Luck, which has just been published by Pelican Books. Now, sadly, we missed the book launch due to family events and catching the flu, but my colleague Marianne Freiberger met up with David afterwards to find out more about the book. They touched on a really fascinating range of topics, from double yolked eggs to the Bay of Pigs, why it's essential to disagree, and why probabilities, essential tools for statisticians, don't actually exist. Marianne started out by asking David why he chose to start the book with a rather personal account of all the fortuitous things that had to happen for him to even exist.
Yeah, I don't know. I wanted to start off with this feeling of the fragility of our existence, because although it's not a book of philosophy, I do deal with, how we view why things happen and why things don't happen. And we might have a view of, that there's some external force, fate, destiny, the will of God, or something like that. Or we might think what happens to us is just sort of happenstance, randomness, luck, chance, whatever. Whatever our view, I don't think it actually matters that much. The crucial thing is that we don't know why things happened. What we do know is that very small events can have very large impacts in our life. And the biggest impact, of course, is why we're here in the first place. So I talk about my grandfather, who was in the First World War and did an incredibly dangerous job as brigade gas officer just after the Battle of Passchendaele on the Western Front in 1918. And he lasted 3 weeks in the job, which I think was quite good going. I think he was quite lucky to even last 3 weeks before he was blown up by a shell. But what he ended up being was incredibly lucky, is that he wasn't killed, and he was sent back behind the lines, and he managed to stay behind the lines for the rest of the war, which I think certainly saved his life, because his battalion were then moved into the Somme, which was then a quiet sector. But then in March 1918 met the Kaiser's offensive, 1 million soldiers attacking them, and they had to make counterattacks. And he was a second lieutenant. So he would have been first out of the trench, blowing his whistle, getting his men to follow him. And he wouldn't be here, and I wouldn't be here. And not only that, my parents had to be born, they had to survive. My mother was...
She was captured by
pirates in China in the 1930s.
What happened there?
Oh, she was living in Shanghai, and their whole boat, the pirates thought their boat the school children were on was carrying bullion. And in fact, it was just, they captured a whole lot of school kids. And an English gunboat had to come out and rescue them, and it was on the front page of the New York Times and front page of the British newspapers. Anyway, and then she left Shanghai under shell fire when the Japanese were invading, and so she did all that. And then my father only just survived having TB in the war, and then so all this event, and then finally, I was conceived, and here I am. But that was massively lucky. Again, I looked at the time of my conception, November 1952, and it was a real cold snap in North Devon.
So it was the cuddling up?
So they were, yeah, exactly. I don't know the exact circumstances, of course, but it could so easily not have happened.
So that's quite a personal story.
Yeah.
And you do say that uncertainty is a personal thing. What do you mean by that?
That's the point I want to make throughout the whole book, is that I think of uncertainty as a personal relationship between us and the outside world. There's a nice definition that I stole, the conscious awareness of ignorance. So it's the acknowledgement that we just don't know. But we don't know, as in somebody else might know. It might be just a fact about the world, but we don't know it. It might be the future and nobody knows, but some people might have more idea than others. So in our personal lives, we have to negotiate a world that is, to us, largely uncertain. And that's really what the book is about.
Now, in mathematics, we have probability theory,
Yep.
and in statistics, I guess.
Yep.
And some of it at least thrives on the idea that you can't put some sort of objective measure on it. You know, if you have a die, you roll it, it's a 1 in 6 chance.
Yeah.
So what does that then actually mean, that probability?
Well,
and does it even exist?
It's not a 1 in 6 chance. It's you assume it's a 1 in 6 chance by looking at the die and seeing whether it's vaguely symmetric. I do a trick where I just flip. I was doing it at a show on Friday with 500 people, and I flip a coin saying what's the probability this is heads. And then, of course, I've got a beautiful 2-headed coin that I use. And so you were wrong. You know, you just made this assumption about what the probability was. And you can't even say, I don't think, that die has objectively a certain probability. You could, in theory, I suppose, purely as a theoretical construct, think, well, if I kept on flipping it again and again in identical circumstances for an infinite number of times, it would converge to some number, but maybe it wouldn't. It would veer around all over the place. And while in certain circumstances, like dice and coins, you could possibly think of it that way, that's not the case for any other way in which probability is used. And most of the time we use probability is in the sense of our uncertainty about a fact, about the world, or about what's going to happen in the future. There's no repetitions there at all. You could try to theoretically embed it in some sequence of objective events, but that's not... so basically, and I might as well jump straight to the philosophy that I leave for a while in the book, is that I actually believe probability doesn't exist. I just think we made it up.
So it doesn't have any real meaning.
It doesn't have it's not an objective property of the real world, except, and I've got to say this because I've got to say this quickly, and except at the quantum level. Possibly. Probably.
Because the quantum level is actually built into the laws of nature.
Exactly. But I'm not talking about that. In fact, I don't care about that at all. Don't ask me. I couldn't care less because I don't think it influences our daily lives.
But what about, so there is no probability, it doesn't make sense, doesn't have a real meaning.
Yeah.
So when we use this idea that a large number of trials of something are gonna tell us something about reality.
Yeah.
So, and I notice you have a chapter about the COVID vaccine.
Yeah.
So that is based on the idea that we've done clinical trial,
Yeah.
it's safe, there's quite a lot of people who are still scared of it. So how does that relate then? Does that mean that doesn't work either, that there's a fundamental...
No, it can work as long as you realise that it's a construction. It's a mental construct. It's not actually there. So I use probability. I've been a statistician for 50 years and I use probability all the time, both in terms of when I'm working in a classical framework, in terms of p-values and confidence intervals and all that stuff. I do Bayesian statistics and where it's even more based on probability. And it's very useful to act as if they do exist. So the standard aphorism from George Box, all models are wrong, but some are useful. My aphorism is probably doesn't exist, but it's often useful to act as if it does.
So I'm trying to think of an analogy. So George Box's thing is about mathematical models. Is there another analogy more familiar from real life where we pretend something exists and that's a very useful thing?
Well, I think if you just look at most random number generators don't have any randomness in this at all. They're completely deterministic. It's just a chaotic system in which the numbers generated are totally unpredictable.
Yeah, so a lottery machine...
And a lottery machine is completely deterministic.
Yeah, because if we
There's
knew
no randomness
everything...
there. Yeah, it's Newtonian physics, all these balls bouncing around and we pick a ball and we pretend it's random. Shuffling cards, there's no randomness there.
But it's the complexity of the system and the chaos.
Exactly. We interpret, quite reasonably, unimaginable chaos and complexity. It is effectively random, and it's really good to act as if it is genuinely stochastic. But
Great.
It isn't.
Yeah, great. So that's a good way of looking at it. So we might be dealing with something that's not random at all.
Yep.
Totally deterministic. We, in theory, could calculate it all, but we can't. It's too complex or it's chaos. So then it helps to think of probabilities to
as being an expression of effective randomness. But you can check it, just like I check in the book, the randomness of the lottery balls. All the random number generators are constantly being checked. The premium bond, the machine that chooses the premium bond numbers. That has to be checked. I write about the history of that, who did it. Everyone has to check that because it's not actually random.
Yeah.
It's just unbelievably complex. And similarly, when we talk about clinical trials or events, all the stuff we do scientifically, there's no randomness there. Somebody, takes a drug and they recover or not for unimaginably complex reasons, but it's not random. It is actually just complex deterministic, but it is indistinguishable from something that is random. So, as I say, I'm not going to argue. I don't want to talk about, although I do a bit in the book, about whether the world is genuinely deterministic, stochastic, whether we got free will or not. It all, you can get into this stuff. I say I don't care. All I care about is the fact that I don't know. It may all be the will of God. We may be sitting on turtles all the way down. I do not care because I'm only concerned with a reasonable expression of personal uncertainty.
So you don't care what makes all this happen, if it's deterministic or not, because you basically deal with what you see and what you know.
What I see and what it's conscious awareness of ignorance, and I try to put a number on it. But I do very strongly argue that it's really valuable to try to put a number on our ignorance and not to use words like might and could and may, which are potentially catastrophic, the consequences of not being clear about the degree of your uncertainty.
Can you give an example of when it's
Well, the one I do in the book is quite an old one. It goes back to 1961, which is the Bay of Pigs invasion of Cuba. I was alive then, although I can't remember the Bay of Pigs. When the CIA, Castro had taken over in the Cuban Revolution in 1959. CIA plotted an invasion of Cuba by 1,500 Cuban exiles, and President Kennedy, when he became elected, didn't have a clue and didn't know about this at all. It was completely secret. And so he found out about this and commissioned an intelligence report. And the intelligence report thought it was a really bad idea. They thought it had a 70% chance of failure or 30% chance of success. But that number was dropped from the final draft of the report that went to the president. And for some reason, they substituted the term a fair chance of success, by which they meant not very good. And, this was misinterpreted. And, of course, that's not the only reason he approved the rate, but he did. And it was a total shambles. And since then, intelligence agencies have really led on this idea of trying to avoid what some NATO analysts call variants of vague verbiage, which is using words like likely and could and perhaps without saying what you mean. So, for example, in the UK, there's a public yardstick that in the intelligence agencies, if they say anything is likely, they mean between 55% and 75% probability. It's a completely subjective judgment. There doesn't have to be any analysis or data behind that. It's a judgment, but everyone knows where the ballpark that they're working in.
Sounds like a shipping forecast.
The weather forecast, they will use 10, 20%, 30%. And similarly, theirs will be based on modelling, although they used to be based on judgment, the probabilistic weather forecasts. But they're all similarly the same. They're probabilities that are given to events, which then can be compared with reality. And I go in the book a lot about emphasising the real value of putting probabilities on future events or on things you don't know, and then checking them using this idea of scoring rules. And I use a scoring rule in the book, which is one that was developed in weather forecasting and is the one used in all the super forecasting competitions, which I really promote as being a brilliant idea, in order to check whether people are good probability assessors, because you don't want people saying something's going to happen 90% confidence and it keeps on not happening. You need to be able to detect that really quickly.
And so there are competitions of forecasters.
Yeah, and I write about them because they've shown that there's certain sorts of people who are rather good at this, and the people who are good at this have got the characteristics that I hugely promote in the book, which is have you heard of this thing? They're foxes rather than hedgehogs.
Yes.
Foxes rather than, which is a standard thing.
But maybe you can explain.
Yeah, okay. So a hedgehog knows one big thing in the old Greek story. So there's people who have a particular way of seeing the world. They're within an ideology. Everything is actually channeled through that ideology. They think the world works in a certain way. Foxes have no ideology whatsoever. They're incredibly adaptable. They learn a new piece of data and they can completely throw out everything they thought before. They're very rapid to change to new information. They're very flexible. They deliberately search for new sources of information. They work together. They're just adaptable. And those are the people who make good probability forecasters. And of course, they're always willing to give probabilities. They got humility. They got humility. They know they don't know everything, so they're not overconfident.
Yeah.
So what this shows is that certain personality characteristics, and people can be trained to be better at this, are incredibly valuable. So the book is not about management science or anything like that, but actually, I do promote, like other people do, the real value of having a variety of opinions whenever you're making any judgment, not just relying on one opinion because of the possibility of them being thinking a certain way, not actually trying to avoid this idea of trying to avoid groupthink by trying to almost avoid a consensus by deliberately setting up multiple competing teams, including this idea of a red team, who are the miserable ones. The ones really come at it from a critical viewpoint, who are not subject to the standard ways in which everybody thinks. So, and they're always difficult. Red teamers frankly can be a real pain because they spot holes in everything and they try to puncture, in fact, this general enthusiasm. I could do that. I'm an appalling optimist. I think everything will go all right. So my partner is a one-woman red team to point out to me the fact that actually there's also stuff that could go wrong. Shouldn't we think about it? And I think, oh, for goodness sakes, don't be so negative. And she's always right.
Yeah.
So it's great to have these different perspectives.
It reminds me a bit of people told me people who were on SPIAM, which was one of the organizations that fed modeling results about COVID to the government or to SAGE.
Yeah.
And they said they had this tell me why I'm wrong thing where, people would say something, what they believe, like say they have an estimate of the R number for that week. Yeah. And then that said, tell me why I'm wrong. What did I do wrong?
Well, exactly. So, I put in the book, I promote SPIAM's approach and I even show some of their estimates for the R number for a week. Because, bless them, they had, I think, 8 different teams with 12 different models varying hugely in what they were doing. But essentially, they had almost the same sources of data, trying to come up with the same number, the average number you'd expect someone to infect from COVID, if they've got COVID, and they came up with very different answers. They had estimates and intervals. The intervals didn't even overlap much of the time. So it would have been disastrous just to talk to one group or use one model. But then they got together and did all this tell me where I'm wrong, and then they combined all their estimates into a single judgment with a lot of uncertainty around it. So I thought they really set an example of having this idea of multiple independent groups looking at the same problem. Same with climate change modelling. I don't think climate teams should talk to each other. I think that until the end, I really think you need independent groups thinking differently.
Now, coming back to your book, which is here in front of us, not coming back to it because you're talking about it all the time, but coming back to the physical object that is the book, you've got a picture of a fried egg, 2 fried eggs.
No, it's not 2 fried eggs.
It's one that has 2 yolks.
Yeah.
Right, that's what I was going to ask. So what's the chance?
People say, why are there 2 fried eggs? It's not 2 fried eggs.
What's the chance of having 2 yolks in it?
It's about 1 in 1,000.
Is that why you put it there?
Yeah, because there's a story that comes up in the news, fairly often, where someone buys a box of 6 eggs and they all got double yolks. And the particular there was an example a few years ago where they got a man from the Egg Council along who said there's 1 in 1,000 chance. So some bright spark did the calculation. Oh, that means the chance of this happening is 1 in 1,000 times 1 in 1,000, etc. 6 times, which means 1 in a million. Now this is clearly complete nonsense. Because, we even with the billions of eggs we eat each year, I worked out you'd have to wait for 500 million years before this happened, and it happens all the time. So it's clearly wrong. So
it's a particular hen or a particular...
Well, no, the point is that I show a photograph in the book of me with 6 double yolked eggs in one pan. I bought a box, crack them all open, they all are double yolks. So there's a pan. So how did I do that? Amazing. Is it a 1 in a million chance? No, it isn't. Because you could go to my local supermarket and buy a box of double yolked eggs.
Oh, you can?
Yeah.
I've never seen those.
Yeah, no, you have to. Very hard to go to a very special supermarket. I bought them in Cambridge. You buy 6 double yolked eggs because you can tell a double yolked egg. You hold it up to the light and you can see it's double yolked. So they can be spotted and sorted. And I mean, presumably, when people do get a box of double yolked eggs, it's when they've been sorted and just been put into an ordinary box.
Interesting.
So
all right.
in a way, there's no chance. There's no, it's all again. It's like me asking what's the chance in using a 2-headed coin. It's sort of your assumptions are completely wrong about how these things occurred.
And also, could it just be that if a particular, a particular
oh yes, they are
prone
clustered
to
within.
it, yeah,
They're clustered
yeah.
within flocks and things like that. Particular hens, and so once you've got one, hugely increases the chance the others will be double yolked as well. So they do come in clusters as well. So all sorts of things are there, which means that this assumption that people have is just wrong.
That it's independent and that
yeah.
Okay, so last question potentially. What would you most like people to come away with after reading your book? What is it?
I don't know. I hope that they enjoy it and laugh. There's some good stories in there, and also there's stories about gamblers, stories about everything and disasters.
Tell me one of your favorite stories, like fun.
Yeah, one of my favourites concerns Darren Brown, who's a UK illusionist who does all these extraordinary things, on television and on stage shows. And in one of his programs, they filmed him flipping a real coin, 10 heads in a row, and he just did it very casually. Here's 8, 9, 10. Thank you very much. And the film was not fiddled. He really did flip the coin 10 heads in a row. And later on in the programme, they reveal that minute was after 9 hours of filming, which I think shows enormous professionalism. He stood there for 9 hours flipping this coin. And then he finally got it. But when he showed it, it looked like it was his first time. He was dead cool about it. He must have been so excited as he got to 8, 9, 10. He thought, Christ, will I be able to go home at last?
So he literally just kept going.
He just kept going with the film camera running the whole time, and then they just used the final minute. But you just have to admire his extreme professionalism there.
And of course, we admire David's extreme professionalism in everything that he does. David's new book, The Art of Uncertainty, How to Navigate Chance, Ignorance, Risk and Luck, is published by Pelican and is out now. We'll put a link to it in the show notes. That's it for this episode. If you've enjoyed it, please do recommend us to a friend. And if you like, you could rate and review us in your podcast app, which will help other people find us. Thanks for listening, and bye-bye for now.